What's up? This is Dr. Taylor Crick, host of the AutoImmune Doc podcast, and I've got a really fascinating video today about melatonin and mitochondria, and some of the new research that's coming out about melatonin, and even in the last 5 to 10 years, certainly the research is just pouring out. I had somebody ask me over the holidays, family members asked me. They said, if you could say one word, what's going to be like the hottest topic in science in 2023? And quite frankly, at first I was stumped. I was like, boy, I don't know. And I just thought about it. And I said, melatonin. And they said, really? And I said, yeah, melatonin research is crazy. So we're going to go through this. I'm going to show you a bunch of studies today and just show you the current research. Obviously, at the end, I'll talk about dosaging and things, but this is not medical advice. I'm not saying that you can use it to treat any of these things. It's just being studied for all of these things. And when you understand kind of how the paradigm is shifting and how the science is shifting, you understand how, like, wow, this is why people are doing this. I got intrigued by this from hearing about it through the long COVID world and just through, the practitioner world of just knowing that people were dabbling in high doses. I had heard about high dose melatonin research and coming out of like NASA and stuff like, over 5 years ago. And then it was just still really like novel and new, but now it's getting to be more widespread. I've had patients come to me that have been dabbling in it. The research is pouring out. So it's just really, really fascinating. So today we're going to talk about melatonin and mitochondria, and in the context of things like COVID, cancer, Alzheimer's, concussions, PCOS, and much, much more. What the current science says about this darkness hormone. So our view of melatonin is changing. Again, like I mentioned, the research is crazy, so I'm going to show you 5 of my favorite studies on it, but it's being studied extensively for cancer, for Alzheimer's, for metabolic diseases, for PCOS, for long-haul COVID, and much, much more. What was previously thought, and what's changing with this a little bit, what was previously thought is that it was made only by the pineal gland. And the pineal gland, we know is responsible for just like the darkness and when the receptors from the eyes going to the hypothalamus and to the suprachiasmatic nucleus and releasing melatonin in response to sleep. And I'll show you some slides and things like that about how melatonin declines as we age and things. That's all true. This is all true. But what we've now found is that pineal melatonin, blood melatonin. So with that too, when you measure melatonin in the blood, it'll be higher at night and it will be virtually non-existent in the day. And as you age, those levels get closer and closer where, if you're above 55, your nighttime melatonin levels are about the same as your daytime melatonin levels, pretty non-existent from a pineal standpoint. So we know that it's declined with aging, but what we now know is that that's less than 5% of total melatonin. So we'll talk about that. Another thing that was previously thought is that it had a negative feedback loop. Meaning, like, if you took more, it would shut down your body's natural production. That's what everybody still says. And there is no known feedback loop. The reason that was thought that is because melatonin is a hormone released by the pineal gland, and that's typically how hormones and glands work. So it was a theory. It's still a theory. It's not been disproven, but there's no known mechanism by which it shuts down natural melatonin production. That just hasn't been shown ever. We now know that over 95% of melatonin is mitochondrial, and there's no known feedback loop for that. What we now know, and again, I'm just skimming through this because the studies are going to show it, and honestly, my fear for this video is I don't want to spend too much time in the studies because there's a ton of them, but melatonin is a powerful antioxidant, a powerful scavenger of free radicals. Melatonin is blood and water soluble, so it can access all tissues and all cells. It can cross the blood-brain barrier, it can access the brain, it can just impact, systemic cellular function. Melatonin exerts its effects via the mitochondria and by altering metabolism, and that's the root of all disease, mitochondrial dysfunction. And I'll show you that extensively. As you age, melatonin decreases, and as you age, oxidative stress increases. And whether those two things are related or not, as up for speculation, but they're just two correlated things that as you age, melatonin decreases, but as you age, oxidative stress increases. It's one of the major theories of aging, the reactive oxygen species. And then, like I said, blood melatonin or pineal is less than 5% of total. Mitochondrial melatonin is 95. And then here's the important part. Here's the kicker from a supplemental standpoint, is that when you take melatonin, it will increase the melatonin in your blood. That melatonin can get into the cells. But the cellular melatonin, the mitochondrial melatonin, doesn't get out, so it can't be measured in the blood, but you can boost melatonin and boost other functions, boost glutathione function, decrease kynurenine function, all kinds of just interesting functions change with melatonin supplementation. So I think that that's really, really important. Another thing that we now know is that many cancer cells and Alzheimer's cells do what's called a Warburg shift. And we'll just keep calling it this Warburg shift because some of the studies are going to show it in that regard. But this is called aerobic glycolysis. In fact, I have this book right here. It's called Cancer as a Metabolic Disease. And it was written, I don't know, 5 years ago or so. I've had it since it came out. But it's all about how cancer starts metabolically from this Warburg shift. So what that is that even in the presence of oxygen, cells will preferentially use glycolysis for quick energy production, especially immune cells. And what happens is, if you get sick or something, cells will switch to glycolysis because it can quickly provide energy to fight a virus or something like that. But then they never shift back. And then even in the presence of oxygen, typically in the presence of oxygen, your body's going to shift and use something called OXPHOS or oxidative phosphorylation. But what happens is these cells get shifted into this carb fermentation and this glucose fermentation, and they kind of stay there. So in COVID and other viruses can also induce this shift. So I'll show you an image in a second that just shows that COVID will induce this Warburg shift, and melatonin reprograms this cellular metabolism, blocks this Warburg shift. That impacts inflammation, oxidative stress, protects mitochondrial ATP production, and more. So here's a graphic. Again, other things do this for sure, but this is just, I've shared this in other, webinars of mine and stuff. And again, in the long COVID world, this is a hot topic. So it says viral infection should induce apoptosis and prevent viral replication, send out stress signals to activate the immune system, but also be tightly controlled by antioxidants. Mitophagy prevents the buildup of damaged mitochondria. Over here it says SARS-CoV-2, like many viruses, is able to hijack the mitochondria for its own ends, inducing a Warburg shift. So there's that word Warburg shift. So in immune cells, this leads to an imbalanced response where interferon production is reduced. Interferon fights viruses. It's a natural killer cell. It fights viruses. It's a Th1 cytokine as well. There's different classes of interferons, gammas, and etc. But they fight viral replication. So it's one of the mechanisms even by which Epstein-Barr virus can reactivate, and one viral infection can reactivate other viral infections because the mitochondria get hijacked and this interferon gets reduced. And then pro-inflammatory cytokines are increased, so you get more Warburg shift, more or less interferon, more inflammation, and then more reactive oxygen species. It says this could be associated with reduced mitophagy and damaged mitochondria that produce more reactive oxygen species. So anyway, that's kind of the background, before I move into some of these studies. So now I'm going to go into some of the studies, and let me just jump right in. So I chose this one first because of its name. Why won't it move? I'm trying to move it. There. So the anti-Warburg effect of melatonin, a proposed mechanism to explain its inhibition of multiple diseases. I'm not planning on spending a lot of time in this study, but let's just look through this and see. I do have some things highlighted here. Let's find some cool pictures. So mitochondria, an ecosystem in which melatonin is produced and functions. In normally functioning aerobic cells, an estimated 90 to 95% of total ATP production occurs in the mitochondria. This percentage may be reversed when cells adopt a Warburg-type metabolism, in which a large percentage of ATP is then manufactured in the cytosol, outside of the mitochondria. The total amount of ATP produced in the average adult human is estimated to be 40 kilograms per day. So that's like 100 pounds of ATP that you produce every day. Some other things, just as we're kind of, scrolling through these studies. I didn't highlight much again. And I highlighted this because the year is so recent. It says finally in 2016, the first serious attempt was made to determine where in the non-pineal cells melatonin is synthesized. So they're talking about how we've kind of come to this understanding that melatonin is produced in the mitochondria. Here's the next one that just shows the relevance of these findings. They're talking about all the findings of antioxidant capacities, how it's outperformed things like vitamin E and CoQ10 and just different things. It said while these super antioxidants were compared with melatonin, they were not better than native melatonin, and for some indices were less effective than melatonin in reducing the inflammatory and pro-oxidative actions mediated by the administration of a highly toxic bacterial endotoxin. So they're administering LPS into rats, and they're saying melatonin was superior. It says the relevance of these findings extends beyond the anti-inflammatory and antioxidant properties of melatonin, inasmuch as mitochondrial metabolism is commonly disturbed in cancer cells, e.g. the Warburg Effect, which melatonin has been shown to reverse. So, even I'll show some of these graphics in here. Let's go to some of these graphics. This is just showing how it helps mitochondrial, production through some things like melatonin blocks HIF-1 alpha. HIF-1 alpha is hypoxia inducible factor, drives a lot of inflammation. Let's just say it's really, really bad. Melatonin blocks it and increases ATP production. Again, I'm skimming through some of these because the other studies, we're going to see this like 5 times by the time we're done. The Warburg Effect, the change is it increases glucose uptake, it increases hypoxia, it decreases PDC, it decreases mitochondrial melatonin synthesis, it increases intracellular pH, it increases all these things, decreases extracellular pH. So that increases your acidic environment, that increases the excretion of lactic acid, that increases HIF-1 alpha, that decreases oxphos and all these things. And the consequences, we get an acidic environment. We get these things that are blocked. I'll show you a better picture of these later. We get decreased oxphos, decreased HIF-1 alpha, decreased DNA repair. Melatonin can block those things is basically what this is saying. This is something called the pentose phosphate pathway, which is another just mitochondrial metabolic thing that can get blocked from melatonin. I'm not going to go too far into it. And I think that is honestly probably it for this paper. This is just showing, again, HIF-1 alpha, very, very important thing, very important in COVID, very important in anemia, very important in any neuro stuff. So anyway, I'm still scrolling just to make sure, but let's just move on to the next study. There's plenty of these. This one's cool. I like the title. Because what they're saying is that vitamin D, has been very famous over the last, decades of, I won't go any higher, for its, role in everything, right? In autoimmunity, in getting sick, in immune function, in cancer, etc. And vitamin D is a light sensor. When you're exposed to daylight, your body makes vitamin D. And we have a problem with the underexposure to daylight today with our indoor lifestyle, and an overexposure to artificial light at night. And both of those are highly, highly studied, but they're saying that melatonin is just the other side of the coin of vitamin D. So I'll show you some things in this paper, just again some highlights. But it says that this is age. So, I'm kind of in this ballpark here, kind of closer to 40, unfortunately. But my melatonin is decreasing. That's, again, blood melatonin decreasing as we age. Here's one that shows just while you sleep. It peaks at night and then goes down with daylight. Here's another one that says that like some of the commonalities between vitamin D as a biological light sensor and melatonin as a biological dark sensor. It has hormone action, it's antioxidant, it's anti-inflammatory, it's an immune modulator, it regulates the mitochondrial, and has pleiotropic system-wide effects. It's found throughout the body. It's found in all these systems, so I'll show you a few things with that as well. In fact, let's keep scrolling. We're going to get to, this is a super long paper, 46 pages, so I'm going to scroll and until I find something highlighted. So I said, I highlighted this just because this is something that I'm interested in. In fact, one of the videos, got a couple videos on our channel, YouTube channel, talking about this, but the kynurenine pathway. In fact, the last video I just released was about the kynurenine pathway. But low levels of melatonin may trigger an upregulation in the kynurenine pathway. It's also associated with long haul, different things with kynurenine and chronic fatigue and neuroexcitation and things like that. Again, this is super long, so let's read some of these. Melatonin is both water and lipid soluble, thereby can freely flow among all bodily tissues, especially across the selective blood-brain barrier, making it likely one of the most formidable antioxidants within the central nervous system. Preliminary research also indicates that it may be an active component in the lymphatic fluid. That's the lymphatic system of the brain that was recently discovered, within the last 10 years. I remember when it came out, but it's out of Virginia. But assisting in the removal of metabolic waste such as amyloid plaques or alpha-synuclein for Parkinson's. Theoretically, based on this finding, it may be worthwhile to dose melatonin so that older adults with neurodegenerative conditions could increase cerebrospinal and lymphatic fluid levels, boosting those fluid levels. However, this concept is still in its infancy. Neurodegenerative conditions share mitochondrial dysfunction in their pathogenesis, meaning that mitochondrial dysfunction is part of Alzheimer's, it's part of Parkinson's, and it's saying that this is a reason why these things, which could be damaged by many factors, may find protection with administration of melatonin. Circadian rhythm modulation, those are some of the things that are most well known, so I'm not really talking about how it can help with jet lag, how it can help with sleep. I think, again, that's the commonly known stuff. Cognitive conditions, dementia, migraine, headaches, eye health, just looking at the titles of these. Tinnitus, whatever you want to call it. Melatonin has been used to treat chronic tinnitus. That's a neuro symptom. Your ears are telling you that there's a noise when there's not actually a noise. It's a neuro pseudoepileptiform activity of neurons. So one study observed a significantly greater decrease in tinnitus scores compared to placebo. So again, I could have highlighted something in all of these categories, but I only cherry picked some things from these studies, but they're all super, super cool. Then reproductive health, pregnancy and fertility. I didn't put much in there, but I highlighted some in some of the other papers that I'll show you. Here's another one, autoimmunity. Promising emerging research indicates that melatonin supplementation may have therapeutic benefits for autoimmune conditions like MS, Hashimoto's, more likely due to its involvement in anti-inflammatory mechanisms, oxidative stress reduction, and modulation of the gut microbiome. There's only a few other that are highlighted in this paper, so let me scroll to it. Super long, as you can tell. Here we go. The upper limits of a lethal dose of melatonin have not been clinically established. So this paper goes into the dosaging and the safety, and they're more talking about from a conventional standpoint, but the upper limits have not been established. A recent review on high-dose melatonin concluded that there's, if they can't find anything wrong, they'll say there's just not enough studies on it yet. So I'm not saying that it's always going to be safe. They might find that there is an upper level of toxicity. I'm not suggesting that anybody be reckless with their melatonin dosage, but there is no known lethal dosage or upper limit. Oral melatonin is mostly perceived as safe based on published reports, even in higher doses. However, there can be specific instances that may necessitate further diligence and clinical oversight. If you're on certain drugs, different things, again, I'm not suggesting that anybody go out and do this on their own recklessly, but the safety is available and out there. And then this is just the last cool picture that I'll show from this one. But it says, how do you optimize your melatonin levels? Well, I talk about this a lot. I've got a lot of videos about circadian rhythms, blue blockers. I'd be wearing mine right now if my light didn't reflect off. I'm weird. But first, you need adequate darkness at night. Again, I track all this with my Oura Ring. I sleep with a sleep mask. I love it. Then you need to reduce artificial blue light at night. You need to use red light at night. You need to reduce artificial blue light at night. Then you need to mess with your diet. Then there's specific foods, cherry juice, etc., that are high in melatonin. I'm not as big on the food sources, especially when you get into these high doses. And then it's supplemental melatonin. That's how you kind of optimize. Now let's go on to the next study and just keep rolling through these. This one I don't have that much to say on. It's just, I think the title says enough. Why won't move there? Melatonin's impact on antioxidative and anti-inflammatory reprogramming in homeostasis and disease. So I'll just show you a couple things with this. First off, here's a picture of that mitochondria. But let's go down here where we have something highlighted. Melatonin has been shown to have pleiotropic effects in numerous neurology, endocrinology, cardiology, fetal medicine, and oncology studies. Moreover, its protective and allostatic effect spreads over many organs and systems that are highlighted in this image. The effects: anti-inflammatory, immunomodulator, antioxidant. It's cerebroprotective, it's lung protective, it's anti-neoplastic, it's vascular protection, cardioprotective. Placental melatonin is very important, the widespread effects of melatonin. So anyway, a cool one. A couple other things that I highlighted from this paper. Melatonin's role in pregnancy has been studied extensively lately, in the growing understanding in its potential therapeutic use to improve maternal and neonatal outcomes. Melatonin is now considered a key signaling molecule between the mother and the fetus, and a new potential candidate in the prevention of complications like preeclampsia or preterm labor, things like that. Melatonin may be beneficial for both the mother and the fetus, mainly but not only due to the antioxidative properties of melatonin. It says that, again, this is preterm birth, but it just says, I just highlighted again a couple things. The authors propose that because melatonin is considered generally safe in pregnancy, that they need to study this. It's not, you can't obviously put anybody at risk with a study, but they need to study its effects for the prevention of preterm birth. Preterm birth is a big unresolved problem of modern obstetrics, but there's a lot of research with melatonin. I'll show you again in another paper, even some other things for this. Melatonin is considered to act, sorry to scroll so fast. Melatonin is considered to act directly at the mitochondrial level, where it reduces free radical formation and protects ATP synthesis by stimulating key enzymatic complexes, complex 1 and complex 4 cytochrome C oxidase. Show you one more picture in this one, and then we'll roll on to the next one. Prenatal programming, vascular effects, cardioprotective effects, cardiovascular medications, cardio risk effects. The cardiovascular effects of melatonin is what that picture is. Yeah, now let's go on to the next one. So here's the next study. My computer's having some recording issues, so I had to stop and start again. But so here's the next study. Journal of Inflammation Research. It says melatonin as a potential regulator of oxidative stress and neuroinflammation, mechanisms and implications for the management of brain injury-induced neurodegeneration. So TBIs, traumatic brain injuries, concussions, lead to neuroinflammation and lead to neurodegeneration. So let's take a look here. So there's a lot of good pictures in this one. More about the brain, again, so super cool. Just the impacts of, the brain is chock full of mitochondria. There's over 1 quadrillion mitochondria maybe in your brain or in your body, but there's just tons. There's 100 billion neurons, roughly, let's say 85 billion neurons, and you've got, let's say, up to 8,000 mitochondria per neuron. And I've seen literature to suggest that it's way more than that. So there's an innumerable number of mitochondria in your brain. This is just the outline of the paper here and kind of the order that the paper goes in, but it talks about the role, just TBIs, primary brain injuries versus secondary brain injuries. I'll show you a picture of that. And the role of oxidative and nitrosative stress in TBI. So here's a picture of the primary brain injury. It might be like me hitting you on the head with a hammer. The secondary injury are the cognitive dysfunctions, the synaptic degeneration, the blood-brain barrier dysfunction, the inflammation, the oxidative stress, the excitotoxicity, and the cell death that comes from that. So the metabolic changes. TBI and neuroinflammation, just going through the mechanisms of this and how brain injury leads to an increase of oxidative and nitrosative stress. And that leads to all these things. So we're going to keep going and say, how does melatonin affect these things? So here's use of melatonin against traumatic brain injury-induced neurodegeneration. It says you get a brain injury, you get these things: activated microglial, activated astrocytes, activation of MAP kinases, release of cytokines, release of chemokines. And then we go into another picture: melatonin as a regulator of oxidative stress in TBI, melatonin as an energy regulator in TBI. And then here's a picture. It says you get a brain injury, but the melatonin blocks the downregulation of NRF2 and glutathione. That's endogenous antioxidant pathways. Melatonin blocks oxidative and nitrosative stress. Melatonin blocks neurodegeneration and neuroinflammation, the way that those two gears play together. Melatonin blocks lipid peroxidation. So again, the pictures are pretty cool, in this paper especially. Melatonin as a regulator of autophagy dysfunction and NLRP3 inflammasome production or assembly. So says there's a picture of this one too. You get brain injury, melatonin blocks inflammasome activation. Melatonin increases mTOR. Melatonin blocks inflammatory cytokines. It blocks oxidative stress. It blocks mitochondrial apoptosis, and it blocks neurodegeneration. So again, a pretty cool paper here about the brain. Now the last one I'm going to show you is probably the highlight of all of these, because it is, go back up to the top, it's melatonin and mitochondria. It's all the things we've been talking about. It's again got some good graphics and images, but let's go through this paper from 2020. So it says here, in contrast to normal cells, many solid tumor cells allow the metabolism of glucose to pyruvate in the cytosol, but restrict the transfer of pyruvate into the mitochondria. This is known as the Warburg Effect. The Warburg Effect, it says, allows cancer cells to rapidly proliferate, avoid apoptosis, and enhance the invasiveness and metastatic processes that are characteristic of tumors. Since pyruvate is prevented from forming acetyl-CoA in the mitochondrial matrix, the activity of the Krebs cycle is compromised, OXPHOS is slowed down, and ROS generation is reduced. These changes are beneficial to the survival of cancer cells. So, talking about cancer, and again, that is the whole theme of this book, again, of cancer as a metabolic disease. The entire book is about that. So, we're talking about the mitochondria. The mitochondria, a mother lode of ROS. And yeah, let's keep going. So, just make sure I'm not skipping anything here. But melatonin, oh, this is cool. Melatonin has taken on the additional responsibilities of promoting the activities of other antioxidant enzymes while suppressing pro-oxidant enzymes. In fact, that's what this picture is showing. But it says, as an example, melatonin augments glutathione levels by stimulating its synthesis. So, I talk about glutathione a lot. Glutathione is depleted from things like glutathione depletion is implicated in cytokine storm of COVID, bad sequelae. Mold toxins deplete glutathione. Smoking depletes glutathione. Air pollution, just environmental toxicity, depletes glutathione. Mercury depletes glutathione. Melatonin raises glutathione by stimulating its synthesis. Glutathione is an important antioxidant that is often present in very high concentrations in cells. In mitochondria, melatonin upregulates the activity of another major antioxidant enzyme, superoxide dismutase, by promoting SIRT3, which allows it to carry out its function of dismutating superoxide to hydrogen peroxide. So those are very, very important things for antioxidants. This is a picture of that. It's not really, honestly, that helpful. This says melatonin in mitochondria, home sweet home. For years, melatonin was known to have a major impact on mitochondrial function, as manifested by its ability to improve the efficiency of the electron transport chain, enhance ATP production, and reduce mitochondrial ROS damage. That's what we want. We want to enhance the ATP production. We want to reduce the ROS damage, and it's in the mitochondria. So this says, importantly, mitochondrial melatonin levels were clearly not related to pineal-derived melatonin concentrations, because in these studies they took rats and they took out their pineal gland and they still had high levels of melatonin. So that's how they found out that it's not only from the pineal but also from the mitochondria. It says melatonin has many, this is about females again. Melatonin has many beneficial actions on peripheral reproductive organs, which have been especially well defined in the female. The concentrations of melatonin in the pre-ovulatory ovarian follicular fluid are higher than in the blood, and adding melatonin to the medium recently ovulated or vitrified oocytes aids their maturation and development. So anyway, oocytes, eggs, and sperm have tons of mitochondria, like 100,000 mitochondria in their cells, so which is an insane amount. But sperm have to have a lot of battery power to swim and eggs they do a lot. They make humans, so they require a lot of battery power. So it's really interesting that melatonin's been shown with all this stuff with PCOS and fertility things, like as we previously mentioned. So here's another good picture that it just says, I just highlighted, evidence suggests that of all cells, mitochondria produce melatonin. Again, here's another one, I just highlighted the title, but melatonin, the interactions with mitochondrial glucose metabolism. And here's probably the best picture of this whole thing and kind of wrapping this up as far as the research with that Warburg effect. So up here it says Warburg effect. It leads to an increase in I think that's GLUT4, like GLUT4 transporters. It leads to an increase in glycolysis. See, there's a key. Doesn't matter, I shouldn't do this right now. But it leads to an increase in GLUT, increase in glycolysis, increase in lactate dehydrogenase, and pyruvate dehydrogenase kinase. So it increases these things, Warburg effect does. Then it leads to hypoxia, growth factors, oncogenes. And melatonin blocks HIF1 alpha, melatonin blocks whatever this is. Melatonin blocks cell proliferation, angiogenesis, metastasis. A lot of these things, even angiogenesis, VEGF, these are markers that are commonly associated with mold and a chronic inflammatory response syndrome as well. Other things that damage the mitochondria. This is saying probably the most important thing with the Warburg effect is melatonin blocks pyruvate dehydrogenase kinase, which pyruvate PDK blocks PDC. We don't want that. We want PDC to be working. So that's one of the ways that melatonin works, is it blocks this, that then allows this to happen, and we get more ATP production. And we get this increased electron transport chain, so more ATP production, and melatonin's effects on all of that. So anyway, it's just interesting. Now, those are the studies. I think they're super cool, but how do we do this? Oh, one more. This one I don't have that much to say, but it's just in my stack of melatonin studies, and parasites are a fascinating topic. Gosh, this is so annoying. The role of melatonin in modulating parasitic infections. So I said, I highlighted in this context, the therapeutic potential of melatonin in protozoan infections, blood protozoan infections, is evident. However, considering intestinal parasites, helminths, and protozoes, reports are rare. Intestinal parasites are known to cause anemia, poor physical growth, poor intellectual development, and impaired cognitive function. So they're saying we don't know about some of these parasites, but we do know about others. And it says the prospect of therapeutic use of melatonin in parasite infections is promising and prompts further investigation. So anyway, that one's just interesting. So then how do we do this? What are the appropriate doses? Again, this is not medical advice. Run this by your doctor, whatever. But this is something that people are buying over the counter. They've been doing for years. A lot of people have tried it for sleep. A lot of people have tried it with their kids. A lot of people have tried it with jet lag, whatever the case is. Conservative doses, and I'll talk about my experience too. Conservative doses, like typical doses, 0.5 milligrams to 3 milligrams. I'll tell you, we sell melatonin. We use melatonin, and I have one that's a 1 milligram. And it knocks me out more than some of the others. So again, what I'm talking about today is kind of this new science of melatonin, this new application. If you're trying to just fall asleep at night, 1 milligram might do the trick. 3 milligram might do the trick. 5 milligram might leave you feeling hungover the next day or have that, next day melatonin effect. With high doses, I have not been finding that you get that. In fact, it's a little bit different. So I'll read that below here, but those are your typical. More aggressive dosages are now being used with success, I should say. And again, this is in long COVID circles, this is in forums and message groups, this is in practitioner circles that I'm in. So the research that I showed translates into the why. Why are we getting clinical success with this? But more aggressive dosages are now being used for issues like neurological issues. So brain fog, TBI, memory loss, anxiety, depression. I don't know as much about mental illness, but anything brain-wise, anything mitochondrial-wise, the kynurenine pathway that we talked about, that can be associated to many neuro issues. TBIs, concussions, people with head traumas, Long haulers, for sure, it's common in long haulers. Chronic fatigue, the ME/CFS community, mold toxicity, heavy metal toxicity, anything with a mitochondrial component. I think this application is starting to seep into those circles. But here's some of the dosaging that's out there that's available: 1 to 4 milligrams per kilogram of body weight. Now, when I first saw that, somebody said that to me, and they said, "Yes, you read that correctly," because that's insane, right? If 5 milligrams makes you feel a little hungover in the morning, 10 makes you feel kind of groggy, this is 250 to 300 milligrams or 200 to 300 milligrams. I've heard of people that I know personally that are using up to 500 milligrams and no side effects. I've heard people using 150 milligrams nightly for many, many months now and no side effects. So there's a lot of variation in these anecdotes and these stories, and it kind of depends on the application and what you're trying to target. I actually just had somebody text me, and I sent her some of this info, and she said, "For how long?" I said, "Well, that's the magic question. I don't know that this needs to be a lifelong thing, or if we just need to use it short term to kind of reset that Warburg effect, or if you've got neuroinflammation, neurodegeneration that's been, a 10-year problem. It might not be a, 1 week fix. I don't know, and I don't think that anybody knows yet. That's what we're all trying to kind of figure out and use this research and use anecdotal evidence and say, hey, it seems safe, it seems logical, it seems plausible, and then we do some trial and error with it. So 1 to 4 milligrams per kilogram of body weight. Then there are also different forms. So there are powders, that's just easier, better absorption. There are suppositories, that's getting some fame. In fact, one that I've heard of from two separate people that I respect, it's called Sandman. I think it's called Sandman. And like one, somebody sent me a picture of it, and it was 200 milligrams of melatonin and 250 milligrams of glutathione. And hers was the CBD free, so they also have them with CBD, and again, with like an antioxidant sleep effect is my suspicion. There's liposomal. So sometimes with liposomal, you don't need the same dosaging. So I know Quicksilver makes a liposomal, and there's slow release, there's fast release. I've been using a chewable that's 10 milligrams. And so here's what I've heard and what I've also experienced. I've heard, and this is on like Reddit forums and things, I don't dabble in that much, but this information is getting out there. But anything like 0 to 20, 0 to 50 is going to have a tiring effect. But as you get into the higher doses, it can actually affect your sleep, and you actually sleep worse. So one night this week, I did 50, and I would say that I slept a little bit worse, but I felt amazing the next day. I felt really clear, my energy. Honestly, it was kind of like the first time I did a ketogenic diet, felt like vroom vroom, like rocket fuel for my brain. But my sleep scores might not have been as good. So this week I've done 30, 35, then I did 50, then I went back to 30, and I've just been tracking it with my Oura Ring. I certainly have not had any side effects. I was nervous. I'm still nervous to get up to 100, 200, etc. But this confirmed what I've been hearing, is that it more had the energizing effect. And even the 30 nights, 130 night, my sleep score was a 91, my readiness score was a 95, and just like rock solid throughout the night, and I do other things to hack my sleep, so it wasn't like that was the only variable, but I was really, really happy with it. I'm certainly going to keep dabbling with this myself. So I just got a 20 milligram capsule. I'm going to keep dabbling with the 10 milligram chewables. And again, there's a lot out there. So my encouragement is, again, with medical supervision, whatever, run it by your doctor, whatever you want to say, but dabble with this if it's something that you are curious about. Again, this is an over-the-counter supplement. It's not medical advice. It's not medical treatment for any condition, but the research is out there on melatonin's effects on mitochondria, and because of that, its effects, the possible effects on things like cancer, Alzheimer's, TBIs, long hauler, mold toxicity, heavy metal toxicity. And that's the world that I live in, is the mito world. So I'm super, super excited about this. And that's why, again, to come full circle, that's why when somebody asked me, what do you think is going to be the hottest topic in 2023? I said melatonin. Now, if you know me, my science interests change quickly. But I don't think this one's going anywhere. But it's always mitochondria. It's always metabolism. It's always neurology. It's always how can we help sick people get well in this chronic and complex disease space. And melatonin, I think, is only going to become a more usable tool in the toolbox as we learn more and see more happening. So thanks for tuning in. Let me know if you have any questions. I'm sure there'll be more coming out about this. Check out my podcast, the Autoimmune Doc podcast. Check out any other resources on this page as far as videos and things like that. If you like this kind of topic, I've got a ton of other content as far as mold or kynurenine pathway or ketogenic diets or different things, circadian rhythms and all the things. So thanks, you guys.